scientists! Welcome to another episode of SCFG Live! It's not spring anymore, so we can't spring into STEM. I'm so happy that you are all here. It's been so long, but I'm glad that we are all together. Now, to remind you, last week we talked about color. Now, we talked about a lot of different things with color. We talked about how color can mix and how color can separate, and how that process of color separation is what's called chromatography. That was a really big word, but something really cool to learn about. Now, I was actually able to make the connection between chromatography and something that I did this week. You see, Dr. Marbles, his birthday is tomorrow. Happy birthday, Dr. Marbles. Happy birthday to you. Happy birthday to you. Happy birthday, Dr. Marbles. Happy birthday to you. I hope he could hear that. All right, well, I was making Dr. Marbles a birthday card, and I was using some of my favorite colors, but I made a mistake, and I accidentally spilled some water on the birthday card. Well, guess what happened? Some chromatography. Let's take a look. Now, I used black ink, but as soon as the water spilled on it, I could see so many other colors. Not only is there black now, but there's blue and orange and some red in there too. In fact, even the purple ink started to separate into different colors. That's chromatography in action. Be sure to look out for that if you accidentally make a spill. Sometimes accidents can be fun. All right, well, today, let's set up our science notebook and be careful not to spill anything on it. Today, I'm glad that Claire said she's hungry because we're doing food. Let's go ahead and set up our notebook like so. Great. Science has taken us to so many different places so far. We've gone to a music concert in our sound episode. We've even traveled to space in our Out of This World episode. And today, we're going somewhere extra tasty because we're talking about food. Now, the warmer weather has gotten me really in the mood for some of my favorite summer foods. What are some of your favorite summer foods? Well, some of my favorite summer foods are ice cream and lemonade. So today, we're going to see if there's science involved in those two foods. Food is really cool because it involves mixing ingredients together. And mixing ingredients together requires two special things: density and temperature. So today, we're going to explore those two things. First, though, we're going to start with lemonade. And I want to bring in Dr. Marbles, because I think that may be his favorite food. Everyone welcome Dr. Marbles.
Happy birthday to me.
Dr. Marbles?
Happy birthday.
Oh boy, he's singing happy birthday to himself.
Happy
Dr. Marbles.
birthday to me.
Dr. Marbles.
Oh! Hey, Hannah.
Hey, Dr. Marbles, I want to start by saying happy birthday.
Well, thank you. I was just enjoying some birthday chocolate milk.
That looks delicious.
Well, it is delicious.
Well, I'm glad that you could join us for today's episode.
Oh, I'm so happy to be here. Hi to you and hi, scientists.
So today we're going to be making lemonade and ice cream.
Yep. I'll tell you, one reason I'm excited to be here is because we're going to talk about my favorite subject, food. The second thing I'm really excited about is that I get to talk about one of my favorite foods, lemonade.
Why do you like lemonade so much?
Well, what I like about lemonade is you can make it really simple, right? Just some lemons and some water and some sugar. But the other thing you can do is you can add things to it. You can make all sorts of types of lemonade, and I like them all.
Well,
But I'll tell you my favorite thing about lemonade.
What's that?
It's sweet, but it's also sour.
That's right.
Makes my face go like this.
That's right. And that's actually because lemon is really acidic. We talked about acids and bases. We talked about chemical reactions. And that's why your face goes like when you drink it.
Like that.
Exactly. Well, today we're going to make a special kind of lemonade called rainbow lemonade. Dr. Marbles, I hope you make something over on your little kitchen area, and we'll check back in shortly, okay?
Sounds good.
All right. For our rainbow lemonade, you're going to need a clear cup, some lemonade, some syrup. You can use pancake syrup, or you can make your own syrup by just melting sugar and water over the stove. Be sure to ask your parents for help, though. You're also going to need some seltzer and a spoon. Now, the cool thing about lemonade is exactly what Dr. Marbles said. You can use so many different ingredients that you might have at home. So if you don't have these ingredients, experiment with what you do have. Okay, first thing is we're going to put some syrup at the bottom of our cup. I put some red food coloring in the syrup too, because that's where the rainbow part comes in. Ooh, you can see that it's really sticky. All right, just like that. Next, I'm gonna put my lemonade in. When you put your lemonade in order to make it look pretty, you need to carefully layer it on top of the syrup using a spoon. Watch me. Perfect. Whoa, take a look at that. It's already starting to look like a layered rainbow. The last layer is seltzer. Now, to make it really pretty, I added food coloring to my seltzer. Looks kind of like slime, huh? You want to do the same thing with the seltzer. Carefully layer it on top of the lemonade using your spoon. Whoa, pretty cool, huh? Now, to make it fancy, you can add a little garnish, like a grape. Woo, looks like my grape went kind of in between the syrup and the lemonade. That's kind of cool. Now, what I love about my lemonade before I mix it up is all of those really cool layers that I see. Now, I wonder how those layers formed. Well, it's something called density. And before we talk about what density is, we need to break it down. And I mean really break it down to the smallest thing possible. That thing is an atom. Now, what are atoms, you may ask? Atoms are the smallest things that make up everything else. Your hair is made of atoms. Your water bottle is made of atoms. Even your dog is made of atoms. Now, atoms are really, really small, so you can't really see them. For example, in a single human hair, there's 500,000 atoms stacked one on top of another. So that means there's atoms in our seltzer, there's atoms in our lemonade, and there are atoms in our syrup. But the way that those atoms look in each of those layers looks a little bit different. Let's take a look. If we were to use a microscope and zoom really, really closely in on each layer, the atoms might look something like this. What do you notice is different between the atoms in the syrup and the atoms in the seltzer? That's right. The atoms in the syrup look like they're really close together, and there's a lot more of them. But the atoms in the seltzer are farther apart, and there's fewer. That's something called density. Density is the amount of atoms packed into a certain space. The more atoms packed into a space, the higher density that liquid is. The fewer atoms packed into that space, the lower the density. I like to think about this like a pool because it's almost the summer. Well, it kind of is the summer. The pool on the left is really crowded. There's a lot of people crammed into that space. You could say that pool has a high density. The pool on the right has fewer people spread out. That pool has a lower density. Now let's go back to our liquids. Which of our liquids has a higher density? Remember, higher density means more atoms in a space. That's right, our syrup has a higher density, more atoms packed into a space. Which liquid has a lower density? The lowest one. That's right, it's the seltzer. because like Bonnie said, there's lots of room in the seltzer. There are fewer atoms and they're more spread out. Now, the cool thing about this is that the higher the density, you can kind of think of it like being heavier. The heavier things will sink to the bottom. So our syrup on the bottom has the highest density, meaning it's at the bottom, while our seltzer has the lowest density, meaning it's at the top. Our grape looks like it's right in the middle because our grape is floating above the syrup, but below the seltzer. All right, now I want to mix these up and see what happens. Before I do that, I want to go to Dr. Marbles for him to make a prediction in a segment we like to call...
Prediction Chicken! Prediction Chicken! Hey, chicken! Woo! Prediction Chicken. Prediction Chicken.
Woo! Dr. Marbles, what have you been up to over there?
Well, you got me thinking about liquids and you got me thinking about cooking. And so I started getting ready for dinner. And I started making my favorite salad dressing. You see that?
Whoa! Dr. Marbles, look at those layers in your salad dressing.
Oh, yeah, look at that. They did layer.
That's really cool.
My salad dressing has oil and it has vinegar.
Huh. Now,
And it looks like the vinegar is towards the top and the oil, Hannah, it's stuck at the bottom.
well, based on what we just learned about my lemonade, what does that tell us about the oil's density that it's on the bottom? Do you think it has a high density or a low density?
Well, what you showed with the pool and all of those atoms, I think the oil has higher density.
Oh, the higher the density, the lower it is on either the cup or the glass.
Yep.
Cool. Now, prediction. What do you think will happen when you and I mix our ingredients?
Well, I hope they come together because I want to make something new, like my dressing. So I guess when we shake it, we'll see if we can get them to mix and come together depending on their density.
Let's try it. I'll call you back once I'm done with mine, okay?
I'm going to start shaking.
All right. All right. Let's give it a mix and see what happens. Whoa. It looks like our colors, our liquids, mixed pretty well. Kind of formed this brown color. Looks a little bit like iced tea, actually. Let's see what happened with Dr. Marbles' ingredients. Dr. Marbles, are you okay? Are you okay over there?
I'm all right, but I've been shaking like crazy over here.
And what happened?
Well, kind of they came together for a little while, but then you can see towards the bottom, they're starting to come apart again.
Yeah.
Like these bubbles of oil are sticking together.
Interesting. Well, your ingredients didn't really mix very well, and my ingredients mixed pretty well. So
They did.
I wonder what that tells us about the densities of our liquids.
Well, I think the densities of my liquids are really different. And that's what's causing it to make it really hard to mix them.
Yeah. And I think the densities of my liquids are pretty similar, which means that they were able to mix together.
Yep.
Wow.
Well, I'm going to keep shaking.
All right, but don't pass out, okay? Take some breaks.
I'm not going to pass out.
Because our next experiment, oh gosh. Oh, I was going to say our next experiment's also going to involve some mixing. Oh, I hope he's okay. All right, well, our next experiment is actually going to focus on temperature. And temperature actually has a lot to do with density because the hotter something is, the less dense it is. In fact, that's actually how hot air balloons work. You see, hot air balloons have hot air that's forming because of the flame that's inside. And that hot air is less dense than the surrounding cold air, which allows those hot air balloons to fly high up into the sky. Pretty cool. So let's talk about our second experiment. We're going to focus more on temperature, and we're going to make my favorite treat, ice cream. Now, for this experiment, you're going to need a few different ingredients. The first thing you're going to need is some sugar. You're going to need 1/4 cup of sugar. I already measured mine out, so I'm actually just going to go ahead and pour it into my mixing bowl. All right, the next thing you're going to need is milk. Milk is a really important ingredient in ice cream. You're going to need 1/2 cup of milk. There we go, 1/2 cup. And I'm going to pour that into my sugar. All right, you're also going to need some whipping cream. You're going to need 1/2 cup of whipping cream. Perfect. All right, I'm going to pour that in with my milk and my sugar. And now the fun part. You want to mix everything together until the sugar dissolves. The best thing to use for this is a whisk. Okay, now for some flavor. You're going to add in 1/4 teaspoon of vanilla. I'm going to add in a little extra because I really like that vanilla taste. All right, now whisk that together until the vanilla's all dissolved. Perfect. Now is the kind of messy part. You might want to do this over a sink or ask your parent to help you. You're going to pour your milk mixture into a quart-size bag. All right, and zip that up extra tightly because you don't want the milk to spill when you're mixing it up. Nice. Now we're gonna place our bag into a bigger bag with 2 cups of ice. Before I do this though, I'm gonna take the temperature of my ice because I'm curious how cold it is. All right. Now, it might take a little bit of time for that thermometer to drop all the way down because the ice is pretty cold, but it looks like it's about 30 degrees Fahrenheit or about -1 degree Celsius. I'm going to write that down in my science notebook. Okay. Now, unfortunately, this isn't cold enough, so we need to add something to make it even colder, and that is salt. You want to add in 1 cup of salt to your ice. That's a lot of salt. Now, the bigger the salt crystals, the better. So if you can find rock salt, that's the best. Otherwise, you can use kosher salt. I'm going to mix this together and take the temperature one more time to see if there's any changes. Whoa, it's dropping down, down, down. Oh my gosh. It's already about 14 degrees Fahrenheit or -10 degrees Celsius. That's a lot colder by just adding salt. We'll talk about why that is in a little bit. Okay, now the fun part. You want to put your milk mixture into your bag of ice. Make sure all of the air is out of the bag and zip it up nice and tight. Now, this bag with salt and ice is actually really, really cold. So you want to use some oven mitts or some winter gloves when you're mixing it up. Next, you might want to grab a buddy for this because you need to mix it for 10 minutes, just like this. All right, now this is going to take some time. So I already have one that was done earlier that I want to show you. When you take your bag of milk out of your bag of ice, make sure you rinse it off because it's going to be covered with salt. Look at this. This is the one I did earlier. Remember, that milk was liquid before, and now it's solid ice cream. So cool. So how did this all happen? Well, while I'm taking a bite of my ice cream, let's talk about it. So what happened was the milk started as a liquid. Now, we talked about in our first episode how things can change phase, meaning they can go from a solid to a liquid or a liquid to a gas. Now, those changes happen when you add heat or cool things down. So in this case, we cooled our liquid down so much that it turned into solid ice cream. That temperature that it hit to turn into solid ice cream is what's called the freezing point. It's really, really cold. Now, once you cool it down enough, it turns into solid ice cream. Mmm, delicious. Let's check in with Dr. Marbles and see how his ice cream turned out. Dr. Marbles.
Kind of mix it.
Hey, Dr. Marbles.
Yeah.
Hello.
What?
Well, what's happening over there? Oh, God.
I'm exhausted. That's what's happening over here.
Why?
Well, I've been mixing this ice cream for like 20 minutes. And I got nada.
Oh, no.
It's like milk.
Dr. Marbles, I think you might have forgotten a really important ingredient.
Which one's that?
Did you add salt to your ice cream? Not to your ice cream, but to the ice?
Did we add salt? Did we add salt?
Oh, no.
Oh, man. Hold on. Why would that have made a difference?
Well, salt is actually really important in making the ice even colder. You see, when you add salt to ice, it actually causes a chemical reaction to occur, which lowers that freezing point and melting point of the ice, making it even colder.
I can't believe I forgot it.
That's okay. You could still use just ice, but it would take a really long time, and I'm pretty sure you'd kind of pass out again.
Well, I'm going to go ahead and add some salt to my ice now and get going.
Okay.
I want some ice cream.
That sounds good. We'll check in with you in a second, okay?
Okay.
So adding salt's a really important component when you're making ice cream at home. That chemical reaction that occurs between the salt and the ice makes that ice even colder. We saw that when we recorded the temperatures of the bag with ice and the bag with salt. The bag with ice was 30 degrees Fahrenheit, but the bag with ice and salt was 14, which is a lot colder. Pretty cool. Now, I'd encourage you to experiment more at home with ice cream, maybe adding in different flavors or trying it with different milk. Be sure to tag SCFG Live so we can see how your experiment turned out. Okay, now for my favorite part of our episode. We have on a super special guest today. We have on Sabrina. Sabrina is the chef and owner of Discover Vegans right here in Boston. Now, I am sure that Sabrina uses science every day in her work, and I'm so excited to learn more about that. Now,
hi, Hannah.
Hey, Sabrina. So Hannah's been talking today about temperature and about density of different ingredients, and I'm curious, how do you use science at Discover Vegan?
So at Discover Vegan, science is incorporated all the time because I'm always taking some sort of ingredient and turning it into something out of this world. So one example I would say that I use science in my kitchen is I can make mushrooms taste like chicken. I can make mushrooms look like chicken.
Well, let me tell you something, Sabrina. That stuff looks delicious.
What's pictured here are my vegan Haitian patties, and then I also have sea moss juices. Sea moss is actually really good for your body, and it has 92 minerals inside of it. My vegan Haitian, I have 4 flavors.
Sabrina, where is Discovery Vegan? Where's the restaurant? Because I'm coming.
So I do not own a restaurant yet. I am currently a catering service.
Oh.
However, my vegan patties are available at Dorchester Ave in Boston, Massachusetts.
Oh, nice.
that's so cool. Well,
Yeah.
Sabrina, one other thing I have to ask you is there's so many people that are watching today, and you've done amazing things with your vegan cooking and the way that you use science. I'm just curious if you have any advice for all the young viewers that are watching.
Don't let anyone tell you that you can't do it. You can do it no matter what, and never give up. No matter what obstacles you go through, keep going, because there are people that you will meet along your journey that will help you get to where you want to be in life.
That's awesome. Let's check in with Dr. Marbles one more time just to see how he is doing. Dr. Marbles?
Hey!
Oh my gosh, Dr. Marbles, that is crazy!
Well, it's my second favorite thing to do with food is wear it.
Wow.
I love pears.
You look fabulous.
Well, thank you.
You're welcome. Well, I'm glad you were able to join us today. Do you have anything else you want to add about food?
Nope. I just found today so interesting. I can't believe we made lemonade, but also ice cream, and it was so easy to make. I'll tell you, that's dessert tonight.
It was delicious. And it was so cool to hear about how Sabrina is able to transform different foods into other foods. Kind of cool.
Yeah, she was super cool. I can't wait to taste some of her food. Me too.
Well, thank you so much, Dr. Marbles, and all of our scientists for watching and joining us. I can't wait to see you next week on Friday at 2. If you are curious to learn more and support Science Club for Girls, please check out our website at scienceclubforgirls.org. We have so many resources there and ways that you can support. All right, well, it's time to say goodbye. This is another episode of SCFG Live. All right, bye, scientists.
Bye, everybody.